Right, good afternoon. Good afternoon. You're welcome to Tutorials with From Eternity the Schoolboy. Today we are going to take a look at physics review of our assignments on physics on the topic work, energy and power, right? Alright, so without wasting time, I want to call on Chinwendo to write the first. How many questions in physics? How many? 3 questions here. I have take care of the first question. Write it out. Then divide the body into 2 equal parts. This one not write well again. Use red. Okay, black. Okay. Okay, number 1 says a stone of mass mkg is held h meters above the floor for 50 seconds. The work done in, what is this? In J, that is J for joule, over the period is A mh, B mgh, C mgh over 50, then D 0. What's the answer again? Sorry.
0. So
how is it 0? Tell us. Shift of the table, huh?
The work that is stone.
And
when a stone of mass mkg is held h meters above the floor for 50 seconds, you just pick up the stone. The example is like this marker, and I picked it up and held it up for 50 seconds. There was no work. There was no work and there was no space. I was just standing there holding the marker.
do it mathematically.
Yeah?
This you said now, do it mathematically on the board.
Mathematically.
Solve it mathematically. Yes. Solve it mathematically. I know. I know. You're waiting. No idea, Chinwe. Chinwe said that she cannot solve it. Who can help her? Niggas don't look at Konye. None of them are working. Niggas don't look at Konye. You see, I'll give you this stool. You are becoming too relaxed on this chair. Can you solve it? Can you see? Hey, what is going on here? This is Martin. Okay, you not do it. Why? But we are there when I gave assignment, right? Swearing to do it. You forgot. If you hear this 1 week everything affect people. That is mostly why I already said I will not try it again. You see, she forgot. But had it been we review the next day, she will do it overnight. In fact, she won't sleep because she know that if she comes here, I'll deal with her. She will do it overnight. But she keeps saying, I'll do it tomorrow. I'll do it tomorrow. 1 week will do what? Pass. And I know that also affected Chinwe. That he couldn't do this. You rushed it, yeah? Okay? 3 of us. That's why you. Yes, your explanation is okay. I understand. I kudos for the explanation, but do it mathematically. That's what I want to do. If I tell you one thing now, you can solve the question. I will not. I want to give people see what. Let me give you people clue. Go back to the. I want us to wait for Izu. But while waiting for Izu, I want people to go back to the beginning of this topic, work, energy, and power. Study what we define as work. Study everything I said about work. If you study it properly, you can solve this question. It's simple. So I'll give us some minutes to do that. While we wait for Izu, because I cannot send him on an errand to go and bring something that we use here, and we are here solving. It's not fair. So while we wait for him, go through what we did for work, energy, and power. Go through it. Go over it again. All right. Are you done? So explain what you did.
I see that we should look for the work done over the period, and the formula for work done is force and its displacement.
Okay.
So you know that if you like what you feel, once you lift the body, a force must be applied to the body. But in this question, there was no force applied. Just so that they held it H meters above the floor for 50 seconds. So the force, you don't know the force, they did not give us any force. So it's zero. Displacement, they did not give us any displacement. So it's also zero. 0 times 0 is 0.
Does it make sense? Does it make sense? Okay, now let me, what you explain is not about, let me correct something here. You know, the body in question has a mass of what? mkg. They didn't tell us anything as regards lifting it up. They just said held. This time there is to confuse you. Hello? Whether if you like, they should hold it for 1 million years. No work done. Do you know why? There is force. The force in this case now is the weight of the body, which is what? The mass of the body times what? Acceleration due to what? Gravity. Hello? The force in this case now is the weight of the body itself, which is what? Mass of the body times what? You know, acceleration is due to gravity is acting downwards. So if you hold the body, for it to be able, if the person cannot hold, if the force the person apply in holding the thing is not enough. Okay. If do you know why the person was able to hold the body for 50 seconds? Do you know why the person was able to hold the body? Do you know why? Because the person applied force that's equal to or more than the what? The weight of the what? The body. True of us. Has anybody carried something? They didn't tell us how the person took that was stone. They just said that the person held the was stone. Maybe the person may be Chiwando, and I may carry the stone from somewhere and come and put in her hand. She's standing like this and holding the stone. True of us. For like 50 seconds. He did no work, she did no work. Now, but are you also aware that if I carry the same stone and place in her hands, and all this force, all the energy, all the force she applied to hold the stone, if the weight of the stone is greater than the force she applied to hold the stone, she cannot hold the stone. If I drop it, he will just fall with the stone. Two of us, she will fall with the what? The stone. You see her, she go in now, she will cry herself and fall or throw it away. Two of us. It's because she can hold the stone comfortably if the force she apply is equal to the weight of the stone. But she will hear me. If it's just equal, she will hear me. She will be crying. I'm holding the stone. But she will not throw it away. But she will hold the stone. Now, but if the force she applied is greater than the weight of the stone, she just use one hand and hold it and smiling. That's why I can hold this now, because the weight of this thing is small to compare with the force I apply in holding it. There's a force in holding this stone, true or false? But I don't think this thing is so heavy. I will not kill this because the weight will bring my hand down until it fall. That's what happens. So there's a force the person holding the stone apply, and that force is equal to the what? The weight of the what? The weight of the what? Stone. Are you aware that they can place something in your hand? Like you know about this thing they used to do weightlifting, right? Now let me explain this better. I think that will make you to understand better. I can place it in your hands. You may be able to carry it like this. You may stand and place it in your hand like Izu now. Izu may stand, pull off his shirt, and place it in his hand. Izu can carry it like this. But I hear that Izu may not be able to lift it. True or false? And that spot Izu is carrying that weight. What actually happened is that Izu, the weight of the Izu applied a weight that is equal to what? The what? The weight of the what? Lift, right? That's why Izu can just hold it like this. But Izu may try everything to apply extra force greater than the weight of the thing to lift it up. Izu may not be able to do what? Do it. But if Izu can apply force that can lift it, Izu will just do like this and lift it. Am I communicating? Now the person, they didn't tell us that the person lifted the stone up higher again. Are you aware that if the person lifted it up higher again, the person do any work?
Yes.
If the person is standing, I put it in the person's hand and the person lift it up again higher. Did the person do any work?
Yes.
Yes. I'll explain. Just cool down. Let me just explain only what happens when the person just hold it like this without lifting it up again. See what happened. The person applied a force. This force now, the person applied to be able to hold it is the weight of the what? Weight of the what? The body. So this force, the person, so remember that work done is what? Force times what? Displacement. That weight, that force the person applied to be able to hold it is the weight of the what? The body, which is what? M what? G. But because the person did not move any distance again, distance is what? 0. So work done is what? 0 what? Joule. No work done. Because the person could not what? Lift it. Or did not what? Lift it. Now, let's assume the person was actually took it from the floor, him by himself, and raised it. Did the person do any work? Yes. The work the person did now is the weight of the body and the distance and the height the person took it up to, which is H. They didn't tell us that that person lifted it by himself. How even they say the person lifted it, the person, that's work done. That the work done by the person for lifting it is because what? This mg times the height. I want it together. mgh. That's the work done for lifting it what? Up. Also, let's assume that the thing was actually placed in the person's hand, and the person now lift it up, maybe to a particular height x. That's work done. Work done by the person is what? The weight of the stone times that x height. The person took it. That's the what? Work done by who? The person. Does it make sense? So now, because they didn't tell us anything about the person lifting it up by himself or raising it up further, there's no work done, there's no distance by the person. Maybe the work was done by some other person, true of us, but not the person that held the what? The stone. In that case, there's no work done because displacement is what? 0. It's only mg, which makes everything what? 0. So the answer is what? D. Is it clear? Is it clear? Good. Put this explanation down so that we can move to the next question. Izu, go and write this second question first. Okay, the question says, A ball of mass 0.1 kilogram is thrown vertically upward with a speed of 10 meters per second. Please, once you don't put that, that is tautology, clean per or clean, you understand what I mean? So that means per. So I said that you clean per or you leave it. Clean per, just clean per. Then write seconds well, meter per second. They are the same. I hope you know. So you tautology you are writing. Speed of 10 meters per second from the top of the tower on 10 meter high. Sorry, let me say that phrase, please. A ball of mass 0.1 kilogram is thrown vertically upward with a speed of 10 meters per second from the top of the tower 10 meter high. Full stop. Neglecting air resistance. What's this? Is it Chuku? Is it it or what? Is it it or it? Is that what you wrote? Oh, it. Please put it there, not it. It's good. A ball of mass 0.1 kilogram is thrown vertically upward with a speed of 10 meters per second from the top of the tower 10 meters high. Neglecting air resistance, its total energy before hitting the ground is, then G is 10 meters per second squared. That G is small g, not capital G, please. So option A is 5 joule, B 10 joule, C 15 joule, then D 20 joule. I solve it fast. Oh yeah, explain what you did. Project your voice, so don't speak to yourself. Okay? Huh? Mass times what? Energy. Where the formula of what you are solving? How can you start solving physics without a formula? Clean that thing, please. Clean that thing. What are you doing, sir? Clean it. No formula. Is it true? Yeah. What is the formula of what you are solving? This is formula for what? MGH over 30 is formula for what? Which formula is that one? Who solved this question? Huh? Did you solve it? We are not in class when we did it. You are in class. Chichiwendo, go and solve. Go to the board and solve it. Oh yeah. Oh yeah, explain what you did. Chichiwendo.
A ball of 0.1 kg is thrown vertically upward with a speed of 10 meters per second from the top of the tower 10 meters high, neglecting air resistance. Its total energy before hitting the ground is.
What did you write now?
It's not G.
Your G. It's small letter, not capital letter. Okay, oh yeah.
Formula for height is
Which height are you talking about? Continue.
V square over 2 gram.
2 gram.
Yes.
2 gram.
2G.
Okay.
So the height is 10 meter. It's 10 meter. Raised to power 2. So if you now to that G to meter, if 1 gram is in 1G is in 10 meter, 2G you don't know how many. So now do cross multiply. Then you now get 20. Then 10 raised to power 2 divided by 20 will give you 5. Then you see that we find the total energy before hitting the ground. So the formula for it is mgh, and the mass is 0.1 times gravity, which is 10. That is constant. So times this thing that they gave us here, 10 meter per second square plus 5. This 5.
Where did you get? What did you do to this 10 meter high?
Look at it.
What of 10 meter per second? We have 10 meter per second, which is the speed. We have 10 meter high. So what did you do to? You say you are finding the height.
Yeah.
So what? So this height hit the anchor. Actually, this formula you even say, where did you get this formula from? What do you mean of that formula? Where did you get it from? Talk now, where?
From on Google. That's how
You just say formula, just solve a formula on Google, and without even knowing the meaning. Anyway, continue solving. We are here. No be so. We are here. Izu. What's going on? Our star boy is doing something else. Our star boy is starting to go down. Okay, it's 3 o'clock. You can go. What do you get?
15 kg per seconds.
Is that what?
15 kg per seconds.
Is that the unit for what? Which quantity? Kilogram per second is unit for what? Which quantity has kilogram per second at its unit?
Which one has?
We are trying to find something in joule. Joule is kilogram per second. Are you sure? Check well. So nobody can help this lady standing here. So nobody can say save her. Try. Izu, why didn't you solve this thing? When you saw, what did you get? You got 10, 15. 0.1. Izu. See, nobody is able to solve this thing. Let's look at this critically. Let's look at this. Now, the question says a ball of mass 0.1 kilogram is thrown vertically upward with a speed of 10 meters per second from the top of the tower. So look at the tower here. This tower is 10 watts, meter watt, here tower. It was thrown from the top of the tower, vertically what? Upward, with a speed. It was thrown like this. See what happened? The ball fell like this. It was thrown up. The person is standing here. The person threw it up from here, from this top, and the ball will go up like this. At a point, when at this point, we are look up. What are you writing? Keep that pen and listen to understand what we are doing before you can write anything. From this top, when this person was holding this ball here at this point, are we together? So the person now threw this ball upwards. The ball get to this place. There's something that made this ball to start falling down. Well, at this point, the velocity here was maximum. From where he threw the ball, velocity maximum. But as the person that threw the ball here, the velocity will start decreasing, okay? Until the velocity become what? So you can say that initial velocity. Here is initial velocity. This initial velocity is this velocity here. 10 watts, meter per watt, seconds. Are we together? This is the velocity with which the body was thrown up. But when this body got to this level, the velocity becomes what? 0. Here, velocity is what? 0. That's why the body started falling down. Okay? If you throw something up, there's energy you impact on it, in it, that made it to start going up. That is kinetic energy. You impacted on it. So that with a particular word, velocity. So because of the presence of this velocity, initial velocity, kinetic energy here is what? Maximum. Are we together? Are we together? Kinetic energy here is what? Maximum. Because you need energy to go against what? Gravity. Is that energy impacted on it? Because there's a velocity. But when the body now gets to a particular height, do you know why it starts falling? Because the velocity there is what? 0. As it's going up, the velocity you impacted it was moving will be decreasing. As it's going up, the velocity will what? Decreasing. At this point, why it start falling? Oh no, velocity again to go again. The velocity becomes what? 0. That's why the body will start what? Have you noticed that if you just throw something like this without putting energy, the thing will just rise a bit and do what? Fall. But if you put energy to it, it will go higher. Two of us. Now that energy impacted on it, that make it to go very high. We impart high velocity that will make it to go very high. But if you go to the sky, where the velocity becomes 0, it will start falling down. So the more energy you impact on it, the higher the velocity with which it will leave your hand and go up. The velocity becomes 0 at that height. That height, the velocity becomes 0 is maximum what? Height. So here, where the velocity becomes 0, this height now is the what? Maximum what? Height. Maximum height. But here, velocity here is what? The maximum, right? Now, or you say that the kinetic energy here is what? Maximum, better. But at this height now, as the kinetic energy is decreasing, potential energy is what? Increasing. So at this point of maximum height, potential energy PE is what? Maximum. Are we together? Which is what? M what? G what? H. Here that has velocity, kinetic energy is what? Half what? MV what? Are you aware? That kinetic energy is half MV square. Are you aware? Do you know why kinetic energy becomes 0 here? Because velocity is what? What does it say about velocity here?
It's zero.
So if velocity is zero, what happened to kinetic energy?
It will increase.
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 Kinetic energy is what? You told me that kinetic energy is half mv squared. So if velocity becomes zero, kinetic energy is what? If kinetic energy is half mv squared, what is v?
Velocity.
And if velocity becomes zero, what happened to kinetic energy? Hey, are you serious? Kinetic energy is half mv squared. If it becomes zero, what happened to kinetic energy? What would be the value of kinetic energy?
Zero.
It's zero now. It's zero. Zero times anything is what? Zero. That's why at this place now we have V is zero. Kinetic energy is what? Is what? Is zero. Why potential energy is what? Maximum. Now, as the body as the body starts falling now, velocity will be increasing again. Hello? The velocity will what? Increasing. Why the height will be what? Decreasing. True of us. Velocity is increasing. The height is what? Decreasing. Now, because velocity is increasing, here the body has both kinetic energy and what? Potential energy. Here the body has only what energy? Potential energy. Here it has only what? But here it has both kinetic and what? Potential what? Energy. Does it make sense now? When the body hits the floor, bam, at this point now, what energy does it have here? Huh? Surely before it hit the floor, what energy? What energy does it have? Surely before it hit the floor. That's what they're asking. But here, basically here, it hit the floor with high velocity. True of us. Kinetic energy is what? Also what? Maximum here. But potential energy is what? Zero, because there's no height. Does it make sense? So this is how the body keeps changing. As the body is moving from here, kinetic energy high, maximum, potential energy low, is going down, maximum, zero, it is coming down, potential energy, kinetic energy, but once it hit the floor, potential energy becomes what? Zero. Kinetic energy is also what? Maximum here. Now, the question now is this. What is the total energy before it hit the ground? Do you understand what I explained here now? Now, what is the total energy before it hit the ground? Before it hit the ground, does it have kinetic energy and potential energy? That's the question.
Yes.
Does it have kinetic energy and potential energy?
Yes.
Does it?
Yes.
Good. Now, the total energy is supposed to be what? Kinetic energy plus what? Potential energy. That's what it should be. Now, remember that potential energy is what? Kinetic energy is what? Half mv square. Half mass times what? Velocity was square. But potential energy is what? Mg what? H. Mg what? H. Now, we know the mass. The mass did not change, right? Now the velocity here, as it's moving down, the velocity is what? Increasing until it hit the floor. Now, surely before it hit the floor, at this point now, potential energy is what? Equal to what? Kinetic what? Energy. Are we together? Now, that means half mv what? Square is equal to what? Mg what? H. You want to check the heights at which the two of them are equal. Okay? You want to check the height at which the two of them are what? Equal. Now let's go. Here we have mass to do what? So that height is what?
Half V square.
That height is what? Half what?
V square.
V squared divided by what? G. True or false? Is it clear? Because you make here you set the formula, right? Yes. So G will divide, will come under. Remember the inverse. You will do what? Invert it, right? So that this thing will disappear. We have multiplication, right? So that means height is equal to what? Half what? V square over 1 times what? 1 over what? G. True or false? True or false? That means height is what? V square over what? 2G. Does it make sense? Does it make sense? Is that formula you use? But you don't know where it came from. do you not know where it came from? Now, the height is what? V square over what? 2G. At this point now, they say shortly before he hit the ground. Here now, kinetic energy is equal to what? Potential energy. But you need to find the height at which this thing happened. Okay? Now, if you now find the height, you now need to find the what? The total what? Energy. Okay? Now, what is the total energy now? You got them where?
In the total.
Total what?
Energy.
How did you do it?
Half times the mass. 0.5 times v2 times the velocity plus the mass times g times h.
You say what? Say it again.
Half times mass times velocity raised to power 2 plus mass times gravity times h.
Mass is what? 0.1 kilogram. Times G is what? 10. Times height is what? Ablone. Mass is what?
0.1.
Times 10 is what? 1. 1 now. Times 5 is what?
5.
Is it clear? 0.1 times 10 is what? 1. Right? Times height, which is what? 5. Is 5 what? Joule. Here, uncle.
Half times mass.
Half times what?
0.1.
0.1 times what?
10 meter.
Which is 100 now.
Yes.
So 0.1 times is 100 divided by 2 is what? 5. Is what? 5. So the answer is what?
10.
You got 10 joule. But they ticked what? 15. So what is wrong? Are we the one wrong or are they the one? Who? How did you know that they're the one? How sure are you that we are not the one wrong? Are you following us? You look tired. Are you okay? Get them again. Huh? Headache. What's that? You can have way. Do you want to go home and rest? Huh? Please, I want to make a very important information. Please, I want to make a very important point. At any point on this course of the movement of the body, of the ball, at any point in time, total energy is always constant. Know that point. at any point in time, the total energy is always what? Constant. And that total energy is what? M what? G what? H. Know that point. Put it down. At any point, the ball is falling off. From this point to this point, the total energy is always what? Constant. And it's equal to what? mgh. Note that point. Now, if that is the case now, that means whether it is here or here, the total energy is what? M what? G H. Whether the kinetic energy is zero, potential energy is maximum. If you add two of them, you see you have what? mgh. Whether kinetic energy is maximum and potential energy is zero, if you add them, you see you have what? mgh. Please let's know that point. So at this point now, total energy here, P Ke plus Pe will always give you what? M what? Gh. At this point, mgh. At this point, mgh. Now, this point now, and this point, it has kinetic energy here. It also has what? Potential what? Energy here. Just understand that one. And the total will give you, even at this point, where the potential energy is zero, and kinetic energy is maximum. That means what happens here is that here, at this point now, potential energy is equal to what? mgh. Do you know why? Do you know why at this point potential energy is mgh? Do you know why? Because here, I told you that at any point in time that the total of them is what? mgh. So at this point, potential energy here on the floor, on the ground is what? Zero, because there's no height. But Ke is plus Pe will give you what? mgh. And if Pe is zero, that means Ke is equal to what? mgh. Are we together? So here now, here, Ke at this ground, Ke is what to what? M what? Gh. But here, Ke plus Me, Pe is equal to mgh. But on top here, at this maximum height, Ke plus Pe is equal to what? Also equal to what? mgh. But Ke is equal to what? Zero. That means Pe is equal to what? mgh. At this maximum height. But the height here, okay, let me do for this here. At this point now, Ke plus Pe is also equal to what? mgh. But here now, Pe is still what? Is not zero. P is not what? Zero. Do you know why? There's height here. Two of us. There's height. Two of us. There's height. Then Ke. So P here now, Pe plus Ke is equal to what? mgh. At this point, see the height from where it is thrown it up. The height is not zero. Ke is also what? Not zero. Two of us. So two of them will be equal to what? M what? Gh. Now, if you trace the whole course of the body, total whatever energy will always give you what? mgh. So what do we now take as the what? Total energy on landing the ground. That means we should also consider the maximum height. We should do what? Consider the what? The maximum height. How do you know that? You remember here, there's already height of 10 meters here, remember? And here, we have a height was covered here, but you don't know what it is. So 10 plus x will give us the what? The maximum height covered by this body. But at this maximum height, Ke plus Pe is equal to what? mgh. But Ke here is what? Zero. But Ph is equal to what? P is equal to what? mgh. That h there is maximum height. Hello? That h there is what? The maximum height. Now, As the thing comes down here and hit the floor, PE here becomes what? 0. And K is what?
MG.
Is what? MGH. So that means here now, KE is equal to what? M what? GH. Are we together? Are we together? Now, is that all? Alright, let's go to the last question before we.
If a pump.
Go to board and write it. Who wrote this one? You. Go write it on the board. Fast. It's better the question is on the board while we explain, so that if you explain, you can make reference to the question. That's why I wanted to write the question on the board instead of dictating it. Okay, the next question says, if a pump is capable of lifting 5,000 kilograms of water through a vertical height of 60 meters in 15 minutes, the power of the pump is A. 2.5 times 10 to the power 4 joule per second, B. 3.3 times 3 raised to the power 3 times 10 to the power 3 joule per second, C. 3.3 times 10 to the power 2 joule per second, D. 2.5 times 10 to the power 5 joule per second. Chima, go and solve it. Huh? Go and solve it fast. What is it? What is it? Any problem? Any challenge? Huh? Talk now. What is it? You not do it. Huh? Huh? Go and solve it fast. All right. Explain what you did. Project your voice.
If a pump is capable of lifting 5,000 kg of water through a vertical height of 60 meters in 15 minutes, the power of the pump is
Okay.
then power is MGH gravity. Then M is 5,000. That is G.
What do you understand by MG over T? What do you use that formula?
Work done over time.
Why is work done MG here? MGH. Why is work done here MGH?
Because you lifted the water and the weight is 5,000. Like you are the one that lifted it.
Okay. Continue. Continue.
I want to put confusion.
Continue now.
So mass is 5,000. Then G is 10 times height, which is 60. Then over. You say that a vertical height of 60 meters in 15 minutes. So 60 times 15.
Is what? Why do you multiply the 15 by 60?
Because of this, they say this aim. It is that system as in.
Why do you multiply 15 minutes by 60?
Because they say that it is through a vertical height of 60 meters in 15 minutes.
Okay, so is that why you multiply by 60?
Yes.
So what of 60 above?
That one is the height.
That's the height now. It's not 60 meter height. So where do you get the 60 you use to multiply 15? Where do you get the 60 used to multiply 15? Which 60? That is the height now. It's meter, not height. Sit up. Don't lean on the table. Sit up. It's meter, not height. Is this meter not for height? So where do you get the 60 used to multiply 15? Where? You just saw this online and copied it and came here and I'm solving for me without even knowing what I'm solving. Please stop that, please. It's so wrong of you. You don't go online and copy a question. You don't even know how they solve. You don't know the meaning you are solving. Where you get 60 you put here, you don't even know. That's wrong, please. That's very wrong. It's very, very wrong. You have been consistently doing that here. It's wrong. Now you can't even explain where I got the 60 here. The last question we solved, the same thing you copy, or you don't even know what you're copying. You come here and be solving. It's wrong. You're not writing what you copy online. That is wrong, please. I didn't say you should not look up something online. You can look it up, but try to understand why they. If you don't know how they got a particular thing, don't write it here. You don't know it. Imaria. Yes, you can see the question. These things are online. You can see it online and see how they solve it and learn it by trying to find out why this 60 is there. That's when you have known that, not when you carry it in your head without even knowing the meaning. Now you don't even know where 60 came from. Tell me where this 60 came from. Fast. I'm waiting for you. So where did you get the 60 from? Huh? No idea. But you put it. So where did you get this yourself from? Where did you get it from? Huh? Where did you get this from?
It's from online.
You saw city online. And you don't know what it is. You call it height. How can you use height twice? You just crammed it. Stop that. Is not good, please. It is somehow. Now listen. Stay there. Don't clean it. Stay there. Now, remember when you were writing this thing? Are you listening? You remember when you were writing? I told you for you to know if you are giving OBJ. Look at the options you are giving. Know the units you should leave it on. Anyway, basically, it's better to leave it in the SI units. What is the SI unit of time? The time you are giving is in what?
15 minutes.
It's in what units? Minutes. So what are you going to do? To what? Convert 15 minutes to a second before you put it there. Do it by the side. Convert 15 minutes to seconds. What is 30 seconds? What did you just write now? You wrote 30 seconds is 1 minute. Are you with us here? Why are you creating big number for yourself? Do you not know where they got 60 from? Where? They got 60 from 900. What are you saying? So why is there 60 in this thing you saw now in the denominator?
Because the time which they assign it is in seconds. So and 60 seconds is 1 minute. So that's what it is.
So 60 is from where?
Yeah.
It's from where?
Seconds.
So explain it well. Not explain it well. Why did you put 60 there? Why do you multiply 60 by 15 by 60?
Because of the time.
Which time?
This thing.
What about time?
The SI unit is seconds. And 60 seconds make 1 minute. So that seconds is that 60 seconds is this.
You're not explaining this well. Explain it like a science student now. Explain why you multiply 60 by 15. 15 that's 15 minutes by 60. Explain it better. Tell me the reason why you multiply 15 by 60. You don't know. I'm disappointed though, seriously, I am very disappointed. You have textbook, I told you to read textbook. Stop this your online whatever, stop it. Carry your textbook and read. Read textbook first before you do your assignment. Don't go online and pack what you don't know and code assignment. No. If you are given an assignment, get your textbook first, sit down and read. That's what you should do. Get the topic, open textbook, read the topic first, understand the topic. Don't jump online and pick one nonsense online and come here and tell you it's wrong. Now you don't even know the meaning of what you are doing here since. You don't know the meaning. Because you did not read the topic. You go here, you didn't read it. You multiply 60 by 15 because you want to convert 15 minutes to what? Seconds. Period. You know about the verses. You multiply 50 by 6 because you want to convert 15 minutes to what? Seconds. Minutes is not the SI unit of time, even though it's a unit of time. And also the options are in joule per second. Had it been the option is in joule per minute, that's when you can leave it at 15 and use minute to divide. Joule energy per minute. If the options is in minute, sometimes they want to test you. You may see options joule per minute, even though it's not the SI unit, but they can still put it like that to know whether you know what you are doing. In that case, you don't need to convert to what? Seconds. You simply divide by what? 15 minutes. But to be on the safe side, especially when you see option, convert minutes to what? Seconds, because second is the SI unit for what? Time. That's why you multiply 15 minutes by what? 60 seconds. It's actually 15 times 60 seconds because you have already cancelled the minutes. So 15 times, there should be seconds there. I told you not to be putting away unit. You don't listen. It is unfair. I said don't remove your unit while calculating because that will help you to know what you are dealing with. I said don't remove your unit as you are solving. Why are you putting minutes by 15 when you only have seconds there? Where should that seconds be? Is it in front of 15 or in front of 60? What you did here, where is seconds? This you did here, look at it. Where is seconds? Somebody will be doing something without even knowing what they are doing. Huh? If you are given an assignment, open the topic and read. Don't jump and start copying nonsense from online. Read the topic first. Then after reading the topic, you can now open the assignment and start doing the assignment. You may want to see what they did online, but not copying what they did. No, it's wrong. Read the topic first. If you read all these topics before doing assignment, before that was going on, you have covered all the topics without even you knowing, but you will not do it. Your target is just to get the answer to the assignment and pass. That's wrong. Any assignment you do here and you don't know that you don't know that topic, you have not done anything because question can be twisted. It's not true. Question can be twisted. But if you read the topic, if you read and understand the topic, anyhow the question is twisted, you can answer it. You may not see exactly this in your exam. You may solve it and say, hey, I know power, I know anything. You don't even know that you don't even know anything. Because this can be changed. What will you do? But if you study the topic very well, anyhow the question is twisted, you can answer it. Go and sit down. We will not clap for you. Go and sit down. We will not clap for you. All right. Any question? No question. Okay. All right, I think that's the end for. Is there any other question in physics review? That's the end of our physics review for today. All right, thank you very much. See you next time.